So you want to know about AI in 2025. Huge topic. Going to try to distill it down into a really short video here. Start at the beginning. Large language models are generally the AI that you hear about today. So we're going to start there. LLMs are just a type of machine learning model. More specifically, they're a type of neural network. You may have heard about neural networks in passing or come across them in your job. In short, they're made up of three parts. They have an input layer, a hidden layer, and an output layer. Data goes into the input. It gets transformed into a bunch of little data points. It goes into a hidden layer where it gets processed into more abstract versions of the data points. That goes through a couple layers, and then at the end gets turned back into the output layer, which is the representation of the prediction that the model's making. Looking at a neural network, we know what the input is, we can understand what the output is, but the hidden layer is generally too abstract to really understand exactly what it means. That's also where the weights are. When you hear about like weights in a machine learning model, that's the weights in the hidden layer that are modifying your input to the output layer. So when you think about what a large language model is, you would probably generally understand how a machine learning model works. It's trained on a whole bunch of data to be able to make a prediction on a topic of your choice. Maybe that's predicting what the weather is going to be in the next couple of weeks. Maybe that's predicting what your drive time is going to be on a certain day of the week. They're essentially trained to make a best guess based on their training weights. Large language models are basically the same thing. They're just trained on words and language. They take your question in as a sentence, and then they make a prediction on what each word would be in a response back to that based on all the knowledge that they have and their weights. This is really cool because we can actually have a conversation essentially with a machine learning model because it's just predicting what it thinks the response would be to the question we're asking. One thing that's been really cool to observe though, not only are machine learning models able to predict a response to our question, but because written language is really in a lot of ways thought, the machine learning model is also able to sort of think, so to speak, like how a human would. This is a huge unlock for us because now we can ask questions in natural language and have our computers generate thoughts and respond how a human would based on all the information we've got available on the internet. And this is pretty cool because now we can actually have the AI think through problems and give us solutions, but it's still just thinking. And that's where the next part comes in. We realize we can give tools to AI. So now not only can the AI think like a person, but it can do like a person. We can give it tools to browse the web. So now it can Google things and find more information. We can give it a calculator so it can do better math. Or we can even give it the ability to write its own programming code and run it to be able to extend itself or write new applications for us. Not only can it think, but it can do now. The problem is AI out of the box with LLMs, it generally wants to just give you the answer in the first response, not ask follow-up questions, not do any kind of thinking, really just estimate a best guess on a response and send it. What we realize is we can actually force it to take multiple steps and think through a problem-solving process. And we call this chain of thought. And what this is essentially telling the LLM that, hey, instead of just giving me your best guess at an answer right away, first break the problem down into a couple different steps, such as I need to go here, look for certain information, I need to add certain numbers together, do some math, and that gives me a different number that I can then use as the final answer. And by telling it and giving examples of how to break down a problem into steps and then executing on those steps, we can have the AI mimic that and not only come to better answers, but also be a lot more consistent in the way that it treats problems. This is really big for us being able to apply this to a production environment where historically LLMs one-shotting an answer would be a little iffy, sometimes a bit of a roll of the dice on how well it would answer. By forcing it into chain of thought, we're able to get more consistent answers because it's actually breaking the problem down into multiple smaller steps. And so it's more likely to solve it the same way each time. Now, this is great. AIs can now think like we can, use tools like we can, browse the web. We now can break problems down and execute them step by step like we would. But the problem is that AI still need a lot of context to be highly effective. And this is where embeddings come in. So with embeddings, what we can do is I can take my query, and with an embedding system, we can search for data we've already indexed and find things that are relevant to the AI. And we can do this through embeddings, which work essentially the same way that an LLM does. Just like an LLM predicts what the next word is in a sentence, embeddings predict topics, so to speak, on pieces of data. So when I'm asking for laws around kangaroos, it's not going to go grab kangaroo habitat information. It's going to be able to actually go get kangaroo laws and pull those embeddings back that it can now reference in its answer. Now, an important thing to note here is that embedding systems only work with data you give it. So for our kangaroo example, you would need to have PDFs or text files that are all the laws of different states in the US. And you could upload all that into an embedding database, get all the embeddings generated, so that when we go search for the legality of owning a kangaroo, we go and look at this embedding database and it's going to automatically pull any laws that it matches that are related to kangaroos. The way this would look, my question would get forwarded to the system: is it legal to own a kangaroo? That system would then go say, hey, give me all the embeddings and relevant information we have about is it legal to own a kangaroo? And now it's going to give all of that information to the AI. So it's not going to just say the user's asking about laws for owning a kangaroo. It's going to say, here's some laws about owning a kangaroo. The user asked, is it legal to own a kangaroo? And now the AI has a bunch of information to go off of along with my question to give a more successful answer. And this is huge for us using, again, an enterprise to be able to apply that to your knowledge base or standard operating procedures and things like that to make the AIs a lot more consistent in the way they act. Now, going into 2025, you've probably heard a lot about agentic AI. We've got these really fine-tuned AIs that are good at specific areas, maybe on your specific operating procedures for accounting or answering billing questions or picking up the phone to answer inbound customer calls. What we saw over the last couple of years are AIs that just do customer calls, AIs that just do accounting. With agentic AI, we've come to realize we can actually make all these AIs work together and present it as a single AI. So now my company doesn't have 5 AIs, we have our company AI. But when you ask a question, we route that question to the right AI that's the expert on that topic. It can answer, or if it doesn't know, it can hand that to a different AI. Now the AIs can work cross-domain to help each other out and present as a single smart AI, even though there are multiple AIs behind the scenes. This lets us work on much bigger problem spaces. So instead of us having to focus in on these really small verticals, we can actually work on things that are across your whole company. Talking about safety concerns, there's kind of 2 main pieces of this I want to touch on. The first is data safety. Now, if you're a big enterprise, you probably have rules around where your data can live. Can you go into the cloud? What cloud is allowed into? When you're using these APIs for different AI providers, some of them are going to use your data, they're going to keep it around, they're going to train on it. You need to do your due diligence to make sure that that data is going where it's okay to go. There are offerings from things like Microsoft through like Azure where you can have completely segmented data for an enterprise. You really just need to do your own research. It's changing too quickly for me to really include specifics in this video. The other thing that I want to touch on is authorization. And this is the permission of the end user to see data that AI may have access to. The way to treat this is when you think about an AI, think about it like a website. If a user is interacting with your AI, anything that AI can access, you should expect the user to be able to access. No matter how hard you try, a user will eventually jailbreak your AI and have it say something that it's not supposed to say, give it information it's not supposed to give. You should always treat it that any information your AI has, that user is going to have the same access. The way to approach this is going back to how we use AI in applications. Through embeddings and tools, you can put authorization checks at that tool level, at that embedding level. So when a user says, hey, is it legal to own a kangaroo? When the system goes to get information about the embeddings, the legality around it, that system can check. The user is Garrett. Is he allowed to see the laws around kangaroos? And if he is, then grab the embeddings, otherwise don't. That's more traditional software engineering, but you really want to just keep that data completely out of your AI if possible, if the user's not allowed to see it. I could make a whole video about training your AI, so I'm gonna just keep it short for now, and maybe I'll make a follow-up. Most of the time, it's not worth training a full AI for your application. Usually you're a lot better off using one of the flagship models. If you can give one of these big models that are pretty cheap now the right prompt and really give it a lot of context and the right tools for the problem, it's going to perform really well, and you're going to be hard pressed to do better performance wise for less money. If you get to a place where you've used all the embedding tips and tricks you can, given it all the tools, you can't get any further, then I would recommend checking out fine tuning. If you're in a really niche problem space, it might be worth doing because you can help the AI use the right terminology and understand context right. But otherwise, you're probably going to be fine just using something off the shelf. Looking forward into 2025, some trends that you should keep an eye out for. First is chain of thought. We kind of covered this a little bit earlier. The way it's been done traditionally with chain of thought is we actually prompt the models and say, hey, when you solve a problem, break it down into these steps. Now give me your answer. But what we started to see are chain of thought being built into the model itself. This is things like Grok 3 that recently came out, DeepSeek R1, or ChatGPT's O1 model. These are reasoning models is what they call them, or deep think or deep research. There's some combination of usually chain of thought where you can see their thinking along with maybe a web search tool so they can search the web. We're going to continue to see chain of thought built into the models. Instead of having to prompt it, it'll just think out of the box. It is a lot more expensive because those are tokens that are having to be generated. So the context windows have to get bigger. Processing is increasing as a result. So a little more expensive to use, but the performance is usually worth the trade-off. The other thing we're going to see are multimodal AIs. Now we've seen a little bit of this in the past through things like Claude or GPT-4 being able to read images or even generate images in certain cases. The way those have worked historically is very simple. essentially documents you upload get passed through OCR or some other kind of translation layer, and then the results are given to the AI. They give us a PDF, here's the text from it, now give them the answer. That was great, but it's a lot of extra steps, it's a lot more expensive, it's a lot slower, so the response has a higher latency. There's a lot of trade-offs. What we started to see are new models, again, like Gemini 2.0 with its multimodal support. Not only is the AI trained on written language, it also can understand voice and audio, it can understand pictures, even videos in some cases. And the advantage here is that instead of having all these steps along the way to go OCR a document, to take the text, feed that into the AI, or transcribe the audio and give that to the AI, now the AI can understand it natively, which means there's no in-between step, which means our latency is a lot lower, there's a lot less processing, and the AI can understand some nuances that otherwise are missed. Think about if you're transcribing audio. If you transcribe what I'm saying right now, you're gonna get the words, but you're not gonna get how I say them. When you have an AI that's multimodal and it understands audio, not only can it understand what I'm saying, it's understanding how I'm saying it and the emphasis I'm using, the emotion I have. And those all can translate into how it responds. Those are things that are generally missed right now in most conversational voice, or if they're included, they're at the cost of higher latency. So going into 25, I think we're gonna see a lot more multimodal AIs popping up, a lot more real-time voice interacting with different toolings and being a lot more native to the AI rather than being tooling added on top. I know there's one more topic, which is AI voice. I briefly touched on it. I really want to go in depth, but this video is already way too long. So make sure you like the video if this was helpful, subscribe to the channel. If you'd like to see a video on AI voice, please let me know in the comments or reach out on the socials. But until then, appreciate you watching to the end, and I'll catch you on the next one.